Okay, so a diagonal is going to be anything that goes from a vertex and it's going to go across the shape and join to another vertex. Now, why do we need to know that? Because what we need to know is how many degrees are inside of a polygon. Like, you all know that a triangle is 180, right? And I bet you could probably guess that a quadrilateral is 360, right? Do you know why? That's what we're going to figure out today. Why is it 360? And if 4 sides is 360, what if something was 5 sides? How many degrees would that have? What about 6 sides, 7 sides, 8 sides? Okay? Got an idea?
So a triangle is 180.
Mm-hmm.
A square is 2 triangles, so it's 360.
Exactly. Exactly. So how do we figure out how many triangles are in a 20-sided figure?
20 times 180.
So there are 20 of them. So you do 4 times 180 for a quadrilateral?
No.
You do 2, right? So it's not just the number, right? So it's not 4 times 180, but what is it? Okay, and that's what we're going to figure out today. So what we have to do is we have to draw the diagonals to create the triangles, because you're exactly right. We're going to figure out how many triangles are in a shape, and then multiply times 180. But how many triangles? So we draw in the diagonals to figure that out. So you start at any vertex, and you draw to every other vertex. So I can't draw B to C, because that's a side. That's not a diagonal. So then I'll draw B to D. I'll draw B to E. And if I draw B to A, that also doesn't make a triangle, because that's a side of the polygon. So this particular shape has 1, 2, 3, 4, 5 sides. So if it has 5, that's a 5 sides, it has 3 triangles. And if it has 3 triangles, we're going to take 3 times 180 to get the sum of that shape. So 3 times 180, so this is why you have a calculator, because we're going to have to do some of this multiplication today. But 3 times 180, 540.
How did he get 5 sides? That's not easy.
1, 2, 3, 4, 5 sides. You multiply it by the number of triangles. But we have to figure out how many triangles it has, right? So what about this one? 1, 2, 3, 4, 5, 6 sides. Okay? So if it has 6 sides, how many triangles does it have? Okay? So pick a vertex to start. I'm going to pick this one right here. And we're going to draw a diagonal to all of the other vertices. So drawing this, is that going to make a triangle? No, because it's a side. So that one didn't count. But here makes a triangle. Then go across the shape. That makes a triangle. Then we can go here. That makes a triangle. And then again, if I connect my last vertex, it's just a side. So that one didn't count. How many triangles are there? 4 triangles, right? So 6 sides was 4 triangles. So 4 times 180 equals 720. 720 degrees. Okay? Pencil looks awful there. I'm going to switch to a pen to make it look better. Okay, how many sides do we have here? I think it was 7, right? Am I right on that? Or is it 8? 8? Okay, so 8. Go ahead.
Is that okay if we find the triangles a different way from the way you did it?
It depends. So 8 sides is how many triangles? You can show me your way in just a minute, but after this one, we're actually never going to find the triangles again. Because we're going to find a pattern, and after we find our pattern, we're going to just use the pattern. Okay? Okay, so let me say it again. So pick a vertex to start from, any vertex. Maybe I'll start with the top one this time, so here. Okay? Okay, so again, if I connect the vertex I picked to the one right next to it, that one didn't count, right? So connecting it to that vertex doesn't count. Connecting it to this vertex doesn't count. but connecting it to all the other ones, 2, 3, 4. So we've got 1, 2, 3, 4, 5, 6 triangles. 6 times 180. 1080. 1080. Did you see a pattern? Yeah? Every time the triangles is how many less? It's 2 less. And that should make sense because the 2 sides next to that vertex you picked don't count. So you have to take those away. Those don't make a triangle. So it's always going to be 2 less. So the actual interior angle sum theorem says that you can use this formula to find the sum. You take the number of sides, n is going to be the number of sides, right there, number of sides, minus 2, always minus 2, every single time. And we're going to multiply that number times 180. And that will tell you how many degrees is in the shape. So a quadrilateral was easy to figure out because it was 2 triangles. 2 triangles is 360. That was easy to figure out. What if it is a 22gon? Right? Is that, you're going to draw all of those triangles? No, because nobody's actually going to draw a 22gon. That would be ridiculous. So instead, we had to find a pattern so we can use it on things that we can't actually see or physically look at. Okay? So over here on the side, here's some just practice examples. So if you have an octagon, so here we're coming back to the fact that you have to know how many sides things are again. So octagon we probably know. 16 gon, or no, that's a 15, sorry, 15 gon and 21 gon. We know how many sides that has. The one that I'm worried about, the only shape I'm worried about is a nonagon. Do you remember how many sides that is? 9 sides. And the 12 is a dodecagon. Those are the only 2 that I'm worried about you remembering the names for because they're kind of a little bit different and they were new to us. So if you want to write that off to the side, if you see a nonagon on your homework, that is 9 sides. And a dodecagon is 12 sides. The other ones I think you could probably figure out. For example, you might see decagon, decade. You might be able to figure those out just kind of using things that you already know. Okay, so this is find the sum of the measures of the interior angles. Very specific. It says angles, plural. That means all of them. Okay, because in a minute we're going to find not all of them. We're going to find just one. Okay, so you have to be able to tell the difference. So if it's an octagon, we're going to do 8 minus 6. Minus 2, sorry, which is 6, and then times that by 180. So that's the formula that you have to have. What's going to happen is you're going to never write that down, and then come test or quiz time, you're going to forget, do I minus 2 or do I just multiply it by that number? So write it down a couple of times so you can help commit it to your memory, and then after that, go ahead and just subtract 2 in your head and multiply. Okay, so 6 times 180, we actually just did that one. That's 1080 degrees. That's your total. 15 gon obviously has 15 sides, so it's just 15 minus 2, and multiply that times 180. Okay? And then the same thing right here. We would go 21 minus 2, and then multiply that times 180. Those numbers are going to get big. They're going to be large numbers, and that's okay. Okay, the larger the shape, the more degrees it's going to have within the shape. Okay, so 13 times 180. So this is 2,340 degrees and 3,420 degrees. Okay, so how that's going to help us, I'm going to jump ahead a little bit. How that's going to help us, you might have a shape like this. Most shapes that actually occur in reality are symmetric. This one is not. Neither one of these are symmetric. But if we have a couple of angles and we want to know what other angle I need to have, so we have x here and x here. So we want to be able to find those two. Well, we can add those up and set them equal to the total if we know the total. So we have to find out the total first. So we can go x plus 85 plus 156 plus 93 is equal to, but we need to find that total number. And that's where this theorem comes in. It's going to help us find that total so that we can use it to find one particular value. If I know all my other values, what do those last values have to be? Okay, so this thing has 1, 2, 3, 4, 5 sides. So that means I'll take 3 times 180, which is 540. Okay, because this is your notes, you might want to write that down, 5 minus 2 times 180, so that you can look back at it. It's not super important that you can do it right this second, because we're talking about it, so of course you can do it when we're talking through it. It's can you do it later by yourself at home. Okay, and we don't need to solve that. We get the idea. We just need to make sure that we know how to set it up and how to solve it. Okay, so this next one, let's count how many sides that one is. Kind of looks like a barn. 1, 2, 3, 4, 5, 6, 7 sides. So my total will be 7 minus 2 times 180. So 5 times 180 is 900 degrees. And then you would set that equal to all of the angles added together. If you wanted to add all of the angles together and just write that down, so we would do 5 plus 10, that's 15, and then add 9x, add 9x, add 9x, add 10, and add another 5. You can do that as well. So if we go 15 plus 15, add all the x parts together. I did a times, goodness gracious. So check me on this one. I got 57 x's. Anybody else add those together and get 57 x's? Or did I just make that up? I think it's right. Yeah, 57 x's. Okay, good. Thank you. Just wanted to make sure. Plus. It's actually going to be minus, isn't it? Minus. So we've got 0, 0. We've got a plus 1, and a minus 14. So it would be minus 12. Equals 900. And then we would solve that from there. So this is just to help you kind of set up the problem, and I know you can do the algebra to solve it in the end. Okay, now that's all well and good, but in reality, that's not the most common way you're going to use polygons. Okay, so for example, most of the time when you use polygons, you're going to use what's called a regular polygon, which we've talked about that before. And if it's regular, that means all of the interior angles are exactly the same. Okay, so I'm going to write that down just so you have that. If it says regular, that means all angles are equal to each other. So if they're all equal to each other, this is an octagon. So we know the octagon is right up here. It's that 1080. So if 1080 is the total, how do you figure out what each one would be if you know they're all the same? Divide it by 8. Okay? And we're going to do this so many times that there's a couple of shapes where you're just going to memorize them because you do it so often that you're going to just know what that shape is. So 1080 divided by 8 is 135 degrees. Now, I will tell you, when you get to doing some of these problems, there is going to be some times where you're going to get decimal answers for your degree measures, and that's okay. One would be if I divided by 7. Okay, if you divide by 7, it's not going to come out to be a pretty number. Okay, the same thing for 11. Okay, or even sometimes when you divide by 15, it could be a decimal. So decimals are okay when you go to your homework on this, okay? Okay, so just to have it, there is a formula for each regular polygon, so I'll write that right here on the side. So the formula is you do the same thing to find the sum, to find the total, and then you divide it by the number of sides. So that's the actual formula for that. That's what we did, but just so you have the formula off to the side in case when you're doing your homework you would like a formula. There it is. Okay? Okay, now let's do that whole process backwards. Okay? Okay? So that process backwards is, what if I told you what the sum was? So the sum is 2,340, which we could cheat and look above and figure out because we already used that number. But if you didn't have that written above, how could we find the number of sides? Go ahead.
Divided by 180 and then add 2.
Exactly. So if we take that formula and just write that formula, and then write equals 2340, that's exactly what we would do. We would first get rid of the multiplication by dividing, and then we would add 2. You are more than welcome to distribute 180, but why? Why would you want to do that? So it would be a lot easier if you just divide by 180 to get rid of it. So hopefully you understand what I'm saying here. You could distribute this if you wanted before you solved. Okay, that's like Algebra 1. They tell you distribute first, distribute, distribute. It's actually not true. You can just divide, and it makes it a lot smaller numbers and a lot simpler. So if you take 2340 and divide it by 180, you get 13. And then if we add 2, you get 15. So I wanted you to have an example that's worked out step by step, because what you might do is you might just grab your calculator and start typing in buttons, because that's what we like to do, just start typing things in and getting the answer, which is great right now, right here, when you know. But what happens tonight? What happens in a week, right, when you're looking at this, trying to do your homework for the quiz review or something like that, okay? So you have an example fully worked out there, and then there's just one more, 900, which we actually already did this one as well somewhere in our group. But if we go n minus 2 times 180 equals 900, I'm going to give you a second to grab your calculator, solve that one, and see if you can get the answer. We know what the answer is because we actually used it before, but give us a minute. So the answer is, yes, 7. So if you divide by 180 and then you add 2, you should get 7. Number of sides is 7. Okay. Okay, we've just got one more thing to talk about. So we've got one more slide here, and then the rest of it is for tomorrow. So we've been talking a lot about the interior angles, the ones on the inside, the one on the inside, the ones on the inside. Okay, but let's talk about the ones on the outside. Okay, the first thing I need you to know, or the first thing I need you to remember, is I'm going to draw a picture here. So I'm going to draw a triangle, just any old triangle. You can draw whatever triangle comes to you. There's my triangle. Okay. Now I need you to understand where exterior angles come from. Okay. So an exterior angle on your triangle is, you need to watch this first and then you can draw it. You're going to trace along one of the sides and then keep going. Do that. Trace along a side, and then keep going. You just created the exterior angle. Okay? Now let me do that again. I'm going to go along the next side. So trace along the next side, and keep going. Because what we're going to be talking about is we're going to be talking about adding all of those angles together. Okay? Okay, and then draw along the third side. So it's almost like drawing a pinwheel. So what we're talking about is this angle plus this angle plus this angle. What do they all add up to? Okay. I'm going to throw some numbers on there just because I think we probably have an assumption as to what they add up to, but I think you're going to be surprised by the actual answer. So let's start with this one. I kind of drew this so it looks like 90 degrees. So let's just call it 90 degrees. So let's say this one's 90. And then let's say this one is 70. And this one is 20. So we're just working with some numbers, and then we'll kind of figure out what the total of the exterior ones add up to. Okay, so you understand that the ones on the inside add up to 180, right? Wouldn't it be easy to assume that the outside ones then add up to 180? Like if you had to guess, wouldn't that be an easy guess? Yeah. Okay, so let's just guess that they all add up to 180 on the outside. And then let's figure out what they actually add up to. Okay? Okay, so if this one is 90, then this one is 90, right? That's easy enough. If this one is 70, what's the one right next to it? I'm asking you to do something we haven't done for a little bit. What? 110, right? Because it's supplementary, linear pair. 110. Okay, if this one's 20, then that one is 160. So already you can kind of see that they don't add up to 180, right? What do they add up to? Grab that calculator.
360.
360. So these actually add up to 360. Crazy enough, every shape's exterior angles add up to 360. And I'm going to show you why. I've got a little geometry sketchpad thing that I can show you. But all exterior angles add to 360. No matter what shape it is. If it's a 22-gon, the exterior angles add up to 360. So, when you come up to a picture and they give you all of these different exterior angles, what are you going to do? You're going to add them together and set them equal to 360 every time. Doesn't matter how many sides it has. So you would go x plus 2x plus 67 plus 89 is equal to 360. Doesn't matter what shape it is. If you are dealing with the exterior angles, they add to 360. Okay. That's pretty straightforward, so I'm actually not going to do the one that's right next to it because you would just, again, do those 4 things added to 360. But there's one more I want to talk about that's not actually on this page, so I'm just going to add it on the bottom here. So I'm going to write find the measure of an exterior angle of a regular dodecagon. There's a couple of words I'm going to underline so that we can talk about it. Those are really the important words there because the word "and" means I just want one of them, right? So you're going to have to really focus when you're doing your homework tonight. Am I finding one of them or am I finding all of them? It would be ridiculous for me to ask you to find all of them, right? Because every time all of them is 360. So if I asked you to find all of them, it would be 360. I don't even have to figure anything out. So most of the time, if we're dealing with exterior, we're looking for an exterior, so one exterior. So I'm looking for one exterior angle of a regular. That means they're all the same. Dodecagon. So earlier, when we found this, we took the total, 360, and we divided by how many there were, 12. So this time, I'm going to do the same thing. What's 360 divided by 30. So 30 degrees is the exterior. If the exterior is 30, what would the interior be? Go, Jackson.
150.
150, right? Because they should be supplementary, right? They should add up to 180. So this is another way to find the interior, and it's actually a lot faster, and you have to know less information, right? You have things that you already know. So if you can remember that the exteriors add to 360, doesn't matter what shape you're finding. If you take 360 and divide it by the number of sides, find the exterior, then the interior is only a 180 away. So earlier today, we found the interior of an octagon by first finding the total for an octagon, which is a new formula, dividing that by 8, and that was the interior. Another way to find that would be doing our 360 divided by 8, which is 45, and then 180 minus 45. Just another way to do it. Whatever way you find to be easier, totally fine. Okay? Yes, I can. There you go. So that's it. There's a lot of new little formulas, but none of them are super difficult, but you might need to keep your notes next to you just so you have those formulas for today as you're working.